Sure. Hello everyone. Today we show the daily question, Domino and Tromino tiling. Uh, we have two types of tiles, this domino and this type domino. It's shaped like a triangle, and this is like a line up to x1. And the problem is to count the number of ways to tie on to x and board like this, or given the n like this. For this example, one n is equal to 3, and we have 5 ways. Yeah. Yeah. So with the constraints n is not greater than 1000, as we can see, this is a classical dynamic programming problem. Yeah, because when you see the n is at the side middle like 2000 to 1 million, and the problem is to count number of ways. Then you can firstly think about the dynamic programming approach. So we have the broad it have the number of rows is 2, so we have to now we will try to count how many ways to put the each type of domino. The first is to put the one this domino at the end. Okay, then we have let's call firstly we let's call f n, and I call this n is the state of the last state of the column, of the column n. This at the column, as each the column e, we have 3 state. First is the state like this. I use one to represent the last this column, this cell is filled. One is this is first case. The second case is this, and the last case is this. The first case is the top tile, the top cell of the column is filled with domino. And why the bottom is not? The second case is the opposite of the first case, and the last case is 1 and 1. That means this column is all filled. The box and the top and the bottom are filled. Okay, so we can consider this at 1, this at 2, and this at 3. We number it. We numberization it, digitalization, whatever. I don't know. Okay, so now let's count how many cases we have. Okay, for the first case is to put the two the one is to domino to the end, previous domino. We assume sorry, I put it like this. This K1. Just put the one S2 back. The second case is to put the second, but you can see that this is not filled, so we put two domino of the shape to S1 like this. Then we have filled. This is referred to number of way to put dominoes into the board of this could be called size E n, and this is n subtract 1. As number of ways is easily f and n minus 1, and the previous column, the n-1 column is filled, beyond filled, so it's this, right? And we can call it a 3. Yeah. Yes. The second case is this is n, and so you can know that this is n-2, and it's 1, 1, 2. And the third case, we put the two domino on the top, the domino to x1 on the top, but we don't place the same at the bottom, and the only case we have is like this, because this is the only case that you can fill it. In the future with 1, this you can fill it like this, right? So this is another case. The number this stay E, F, N, you see the 0, 1, right? This is n-1, right? And the state E, 1 and 0. Okay, as you can see 1, 0, and we put this domino into the back top, on the top, and we have a symmetric case, the same as the third case, is dash E like this, and we put it to the bottom. Okay, so we have -1 and 1, 0, and this is referred to as minus and 0, 1. Yeah. So some people might ask, why not this case? Why not this? Why not this case? It's just put. Why not this case? We leave the bottom empty or leave the top empty because we can fill it in the future. Because the only way to fill it is to put this tie, and we can use the triangle domino to put it and fill the board. That's why we don't have this case, so just ignore it. Now back to okay, and as you can see, we go through on the case that put the 2x1 domino at the end of the board, and now we move on to the next case that use the Tromino shape. The Tromino, we call it Tromino, like triangle. Yes. So you can see that this Tromino, it can rotate 19 degrees 4 times. So we have 4 more cases like this. Okay. Yeah, we can only place this step if and fill the board if the previous is like this, right? So what is this state? This state is F and 1, 1, and it's come from previous state. The previous state is F -1, yes, -1, and the state is 1 and 0. The same as this, this. Okay, this is case 6. The same as this. F -1 and 0, 1. Next case is like this. So the previous state must be fully filled, because if not fully filled, we can't find a way to put any domino to make it full fill. Yeah. and this state is 7, and this state is Fn, and you can see the last element is 0 1, and it's come from this state is n minus 2, Fn minus 2, and the last state is fully, yes, fully. Okay. The last case is we keep rotating in the Tromino 80 and 90 degree, and we got this case, which can sit at the 8K. This is Fn, I mean this Fn 0 1, and this comes from the previous state. This is Fn minus 2. Okay, minus 2 is 1 2. This is the fully state, from the fully state. Yes, this is the last case. So we all have a case. So just create a dynamic program for function f, and its x. The number of state is 3. 3. But I will make it 4 for easy coding. Okay, f, the limit is 1000. Okay, and the state 4, just for easy coding. Set to 0. I don't know if it works, such as not. So first we fill, we clean the f function. Clean the f function equal to 0. Yes, and the initial state, every dynamic program or recursive formula is have an anchor, or we call it anchor state, initial state. The initial state, and for this initial state is 1 2 3 4 n. We assume that if there's no columns, that's it, n equal to 0, the fully state 3, 1 1 is equal to 3. We consider the fully state is the case that the column is filled is one way. Okay, now we do the bottom up approach. You can implement using the top down, but I think the bottom up is more clear and easy to understand. Yes, we so as we need to mod response equal to 7, and I would like to write the function add mod as increase x by e in the modulo mod is the plus add e, and if it is greater than mod, then just subtract it. Okay, why I write this, because it's reusable, and this minus this is faster than do this. Because the mod operator is really slower than the addition and the subtraction. Okay, just let's check. Let me see all the case again. Okay, first case, add no f e is 1. Okay, Fe 1 and 0 1 is 2. Fe 2 is plus 1. case, the fifth case, F. Okay, F A 3 and 1 E 3 with 1 2 1 2 3 4 5 6. We have a 2 last K. 7 F and 0 1 0 1 is 2. F 0 2 to F and 2, and the one the full mistake is 3, but we must, this only happen if we have more than 2 columns previously, right? The same as last case. This case is the same. F to see 0 1 is 1. We can swap it. F minus 2 and K is 3. Okay, and the answers is F and the answers is we fill up to the end column with the fulfillment statement. That is 3. Yes. Okay. That's this case. Let's check it out. Oh, sorry. Okay. The second case. Okay, the second case you try this. So I forgot it. Okay, check it. Okay. Have a good day.